Welcome to the ET335 How-To video for the Quartus, Verilog, and POS KMap Lab Part 2. Here we have an exclusive OR which we're going to use in the second part of the lab. And you can see the exclusive OR with this extra line here. And exclusive ORs are basically an OR gate that excludes the case of 1, 1. So 1, 1 is still going to be a 0 for an exclusive OR. So exclusive OR in Verilog, x equals a tilde b, which is the shift 6 key. In exclusive NOR, if it had a bubble on the end, x equals not quantity of a tilde b. Here I am showing a KMap, and this is POS, product of the sums. So what we're going to do is plot these and then simplify it, since these four are all close. We're going to convert those, and we're going to drop out the b, and we're going to drop out the c, and we're going to be left with a plus d bar. That's what this simplifies to, and I'm going to program this into Verilog. Okay, let's build a Verilog of our map here. So let's go ahead and create a project. Next, let's build a new project area. And let's call this KMap V2. Assuming that I may have one already for KMap 1. We want to create it. Let's go find a Verilog file, and let's go to our desktop, and I have an OR gate V. I'm not sure exactly how badly this one's been abused, but 484, like I said, probably doesn't matter which one we use since we're going to do a simulation, but let's go to files, and good, that's our OR gate V. So let's go ahead and change that to our KMap V2, and let's file save as, and we're going to go to where we have our Altera files, project 4, and I'm going to call this KMap. How about KMap 2, and oops. And we're going to keep it Verilog. Good, save. And remove. And let's go ahead and work on our file. So we have a simple A and B, A, comma, B, LED is fine for our output. So our inputs are A, comma, B, LED. So we have A, OR, which is our pipe, which is a shift backslash, and we have not D, and that's all this is for our simplification. So let's go ahead and compile it. Three errors. Let's see what I did wrong here. Messages. D is not declared. What did I forget to do on D? Oops. That's because I put B down. It's not. B is D. Let's try again. Now it's fairly simple to find our errors. Just go to our messages and look for a red line and fix it. Okay, so we're successful. So let's go ahead and do a waveform, new, University Program BWF, edit, insert node, node finder. Make sure we have the right file. That looks correct. Double arrow. Okay, okay. Since we only have 2, let's just use the same 10. Next clock is going to be double that, 20. It's going to give us our binary count. And simulation option, let's use Quartus. Seems to work. And let's go to run and save. Green, that looks good. We have a excellent. So let's go ahead and Control Shift. And let's see here, we have okay, let's see, we got more. Let's see here, Shift. So we've got 1, 2, there it is right there. Okay, so let's go ahead and use my snipping tool. New, let's get this out of the way that you can't see. New. Okay, let's check this. A plus D bar equals 0. So here we have a 0. We have A is 0 and D is 1, which is inverted, and this is correct. Now let's go do it the other way. Okay, let's go back and check this to make sure that it meets our original requirement. So let's close this out and let's add all of our variables so we could go back and double check that our reduction actually works. Oops. And let's run this again. And we're going to get some warnings, but that's fine. Okay, so let's go to edit, file, new, and edit, insert node, node finder. Okay, list, that's the inputs now with everything. Okay, okay, so let's go ahead and do our clocks. 10, 20, 40, and 80. Okay, and simulation options, Quartus, okay, okay, simulation run functional, okay, and green so far. Uh-oh. A little more to calculate. Good. So let's go ahead and find. All right, let's do control. And that looks like good. So let's use our snipping tool. Okay. Okay, let's take a look at this and see if it matches our original input equation. So we're interested where it is 0. So we have 0, 0, 0, 0. So here we're going to have A, B, C, D bar. And And that is one of our equations. And here we have A, B bar, C, D bar, and which is 0, 1, 0, 1, which is one of our equations. And we have A, B, C bar, D bar, which is 0, 0, 1, 1, 0, 0, 1, and that's one of our equations. And we have A, B bar, C bar, D bar, which is 0, 1, 1, 1, and it is also one of our equations. So it checks out. This is the correct